Hello students, in this video we'll prove the squeeze theorem. The squeeze theorem states the following. It says that if we have three sequences, given three sequences, AN, BN, and CN, suppose that we have the following inequality, that AN is less than or equal to CN is less than or equal to BN if N is bigger than or equal to N1. So eventually, the AN is less than the CN and the BN are bigger than the CN. And suppose that AN, I'm going to write this notation, converges to A. It's a standard notation for just a shorthand for saying converge to A. And BN converges to A as well. So if both AN and BN are converging to A, then we claim that the CN sequence has to converge to A as well. Then CN converges to A. And so here is the proof. And this proof is a good illustration of just using the definitions and choosing the right value of n. So let epsilon be greater than 0, and pick, I've used n1, I'm going to pick n2 and n3 in n, such that, well, what would I like for the first thing to happen? I'd like an minus a to be less than epsilon if n is bigger than or equal to n, let's say n2, we already used n1, and bn is close to a with an epsilon of a if n is bigger than or equal to n3. So an is very close to a for bigger than n2, bn is close to a for bigger than n3, and cn is trapped between them if we're what? If we're bigger than n1. So let's start out with what these conditions mean over here. So what do these mean sort of in terms of the strict sense of inequality? So we have the following situation over here. We have negative epsilon less than an minus a less than epsilon. And this is equivalent to what? This is equivalent to saying that a minus epsilon is less than or equal to an, and that's less than or equal to a plus epsilon. Likewise, we have negative epsilon less than bn minus a less than epsilon. And that tells us, that's if and only if what happens, if and only if a minus epsilon less than or equal to bn less than or equal to a plus epsilon, So let's use these conditions over here in conjunction with what we have. So what can we say? Let's write down one big stream of inequalities. So we have that if we let n capital be what? Be the maximum of n1, n2, and n3. And with this choice of n capital, I can assume that this happens, and this happens, because it's the largest of all those three, so all three of those things will be true simultaneously for this value of n capital. Now, what can I say? I can say that a minus epsilon is less than, well, I put less than or equal, doesn't matter, less than an. But now an is less than or equal to cn, so this is less than or equal to cn. And then cn is less than or equal to bn by this inequality, so I'm using this inequality next. Less than or equal to bn, and bn is strictly less than what? Over here, the bn should be, we can just, to be completely pedantic, these are all strictly less than, right? There's not, that's even more is true than what I wrote. And then bn is less than what? Is less than a plus epsilon. So if I put these things together, what's the conclusion? The conclusion is by subtracting a, they have negative epsilon less than cn minus a less than epsilon. And this statement over here is equivalent to what? This is equivalent to saying that the absolute value of cn minus a is less than epsilon if little n is bigger than or equal to n capital, being the maximum of those three values. And that is the proof of the squeeze theorem. Thank you very much.